This exercise is related to the questions from topic thermal physics. First 23 questions are already recorded, so I will start with question 24. And I'll share after the session, I'll share the recording of those first 23 questions as well, so you can go through that recording. So starting with question 24. So in the question, the air in a train carriage heats up by due to the people inside the carriage. On one journey, there are 44 people in the carriage. The temperature of the air in the carriage is initially 16 and it rises to 22 degrees centigrade. The doors and the windows in the carriage are closed. So we consider they are like no gas escape. The particle does not change. Calculate the time taken for the temperature of air in the carriage to rise to 28 due to the people in the carriage. The average rate at which one person heats the air is 85 watt. Like average one person gives 85 joules of energy in 1 second. The mass of the air in the carriage is 110 kg. The specific heat capacity of air is 720 joules per kilogram Kelvin inverse. Now, whenever you want to work out the energy needed to change the temperature, or as we need the time here, but it is related to temperature change. So whenever there's a temperature change, which formula of energy we use? We use a formula E is equals to Cm delta T, where E is the energy absorbed or released, C is a specific heat capacity, M is the mass, and delta T is the temperature change or change in temperature. The power is given to us. We need the, so first we write E is equals to Cm delta T. Energy is a product of power and time. So in place of energy, I can write power into time. So P into T is equals to Cm delta T. I need the time, how much time it take to heats up from for 16, originally 16 to 28. So the time will be equals to specific heat into mass into temperature change divided by power. So we'll just substitute the values. The specific heat is given to us, which is 720. M is a mass of air in the carriage, 110 kilogram. Delta T is the temperature change. As I mentioned, the temperature change in degree centigrade or Celsius will be same as in Kelvin. So if it is 16 and 28, change in temperature will be 12 degree centigrade, or we can also say it will be 12 Kelvin. So when you're working out a temperature change, no need the unit conversion, just take a difference of the initial and final temperature, and that will be same in Kelvin. P is a power for one person, it is 85, but there are 44 people inside, so it will be multiplied by 44. So when we simplify, this will give us the time it takes to heat up the carriage from 16 to, so it is 254 seconds. Is it clear, this question? Okay. The next we have suggests why the actual time for a temperature to rise to 28 will be greater than what you have calculated. Look, it's a very straightforward question. Like practically, when you do, like you work out the time as 254 seconds, but practically it will take much longer time than what you have calculated. So, what could be the reasons here? Because what might happen, some of the energy might lost to the surrounding. Like it's not all energy transferred to air. As the people are in the carriage, there's some energy transferred to the nearby material as well. Same thing, some of the air might escape. So air might escape from the carriage or replaced by a cooled air. So as a result, it is replaced by a cooler air. So as a result, it won't be same, or it will take much longer than what we calculated, because we took the ideal case. A cyclist compete in a bicycle race. Before the race, a bicycle tire contain an air at a temperature of 22 degrees centigrade and a pressure of 5.2 exponent 5 Pascal. By the end of the race, the pressure of the tire has risen to 5.6 exponent 5. Calculate the temperature of air at the end of the race. So we use what we'll use the we need the temperature. We can use a pressure law here. Yeah, we can use a pressure law, but yeah, it's fine because if rest all of them parameters, they did not say it is changing. So we can say P1 over T1 is equals to P2 over T2. That's one way of doing it. But remember one thing, that the temperature, SI unit of a temperature is Kelvin. So you are supposed to convert any question, if you see a degree centigrade, you're supposed to convert into Kelvin. So first pressure was 5.52 into 10 to the power 5, and initial temperature was 22 plus 273, because in Kelvin. The second pressure is 5.6 exponent 5, and you will get the new temperature will Kelvin. So whenever you substitute a value of the temperature in any of the equation, temperature should always be in Kelvin. Don't substitute degree centigrade or Celsius. You can also use a formula. The general gas equation can also be used. So you can use a formula that PV is equals to N KT. That is another. So first, the ratio you will work out the first pressure, because rest all the other factors are not changing. So when there's a first pressure, there will be first temperature. So I can say P1 V is equals to NKT1, or I can say P1 over T1 is equals to NK over V. Same thing, the new pressure will be P2 into V is equals to NKT2, or P2 over T2 is equals to NK over V. So NK over V. So because NK over V is same both sides, so we can also say P1 over T1 is equals to P2 over T2. So it's the same thing, but we just derive a short formula to relate them. So I advise students, every time whenever you solve a question related to gases, always write the general gas equation if you want to use, even though other parameters were not changing, but always write this equation first, and no need for solution. You can also say P1 over T1 equals P2 over T2. So actually this formula is derived from the original PV is equals to NR NKT. During the race, the value of a k, you are not supposed to substitute the value of a k. It's a fixed value which will give given in exam. But here what we are doing, it's nk over v for the first equation and nk over v for the second equation. Both are same. So we can say P1 over T1 equals P2 over T2. So we don't have to substitute. It's just we cancel out this common factor and compare over P1 over T1 equals P2 over T2. During a race, small amount of air escape. Explain how would the temperature would be would be affected if allowance were made for this escaped air. So PV is equals to NKT. Now, how the temperature is related? If the N is decreasing, so if I say PV, if I just simplify, PV is equals to NK. So this factor, if I consider as constant, like P, V, K is not changing. So what is the relation between the number of the particles and the temperature? If the number of the particles are decreasing, what will appear? The temperature will appear to increase. So as the n decreases, so the temperature of the particle will appear to increase or higher than the calculated value. Explain why the pressure exerted by the air in the tire increases as the temperature increase. Your answer should refer to molecular momentum and the kinetic energy. This is a structured answer. Static is there. So what is the structured answer? First, the particles in a gas are moving randomly. So first part, the particles of the gas are moving randomly, and temperature of a gas is directly proportional to kinetic energy or the speed. And what will happen as a temperature because we want to relate what we want to relate the kinetic energy and the momentum. As I mentioned, why the pressure increases as the temperature of air increase. So as the temperature of air increases, temperature of as the temperature increases, the average kinetic energy or the mean kinetic energy of a molecule will also increase. As the mean kinetic energy will also increase, the speed of the molecule increases. So as the speed of a molecule increase, the rate of change in momentum as the molecules collide, that will also increase. And if the rate of change of momentum increases, it means the force will also increase. And as the force increases, the pressure will also increase. So how you relate them in a structured answer, first thing we'll mention, as the temperature increase, the kinetic energy of the particle increase. So therefore, the speed of the particle will also increase. When the particles are moving at a high speed, they will have a greater rate of change in momentum or exert a greater force, which create a large pressure. So these are the points you have to list. Is it so? You have to relate. Whenever a static question, it's not like you can there should be a relation between the first sentence and the second sentence. And throughout you are relating the part. Like when we mention the increase in temperature increases the kinetic energy. Therefore, so speed increases. Therefore, speed increase. The increase in speed cause greater change in momentum, greater rate of change in momentum, which cause greater force on the wall on unit area, create large pressure. So that is how you relate the kinetic energy with the momentum. Is it clear, this question?